It's easy to look up at the night sky and just take the moon for granted. It's always there, right? A silent, constant companion. But what if it wasn't? What if, for just 1 hour, it simply vanished? Okay, let's dive into that thought experiment. I don't mean exploded or drifted away. I mean, one moment it's there, and the next, there's just a hole in the sky where it used to be. For exactly 60 minutes, Earth is totally alone.
And that's a fantastic question, Maya. It sounds almost harmless, doesn't it? I mean, the moon is a 73 quintillion-ton rock that's just been hanging around for 4 billion years. It kind of feels decorative, like something we just write songs about.
But here's the uncomfortable truth. The moon isn't a silent observer. It's a critical piece of planetary hardware. It's the gravitational anchor holding all of Earth's systems in a very, very delicate balance. And if you remove it, even for a little while, you don't just get chaos, you get systemic failure.
So, to really understand what does happen, we first have to clear up what we all think would happen, thanks to the movies. Right, so let's just get this out of the way. No, people do not float off into space. The oceans don't leap into the sky, Earth's gravity is still very much in charge, and the moon's pull on you is only about 3/millionth of Earth's. You wouldn't feel a thing.
The very first thing you'd actually notice is just the darkness. A full moon gives us about 0.1 lux of light. When that's gone, it's not just a cloudy night dark. It's an unnatural, unnerving kind of dark. The sky feels flat, empty, incomplete. And that's when things start to quietly break. The first major system to fail isn't on land. It's the planet's circulatory system, the oceans. Let's see how this builds. Now, what's really interesting is that tides aren't really waves. They're the planet stretching. The moon's gravity is constantly pulling the oceans into two massive, predictable bulges. This stretch is stable, it's constant, and the rhythm of all coastal life depends on it. Okay, so the moment the moon vanishes, the gravitational force holding those bulges in place is just gone. Trillions of tons of water collapse. But because water has inertia, it doesn't just settle down. It violently rearranges itself across the entire seafloor in a single sharp shock. So this isn't one giant wave. It's something weirder. It's a total desynchronization. Harbors suddenly drain, currents lose their timing, and entire coastal systems just misfire. The global rhythm is broken. This analogy from the source material is perfect. The oceans are still moving, but the timing is completely gone. Everything is offbeat, unpredictable, and that is way more dangerous than a single predictable disaster. While the oceans are sloshing around, the problem is escalating. We go from the surface of the planet to the very axis it spins on. You know that 23.5-degree tilt that gives us our seasons? Well, that's not a given. It's held stable by the moon's constant gravitational pull. The moon is Earth's anchor, and it's what keeps us from wobbling all over the place. For 1 hour, that anchor is gone. Now, the planet doesn't flip over, but it does start to wobble more freely. The Earth's crust subtly relaxes and shifts. This doesn't cause immediate earthquakes, but it rebalances stresses all along the fault lines. The entire planet becomes, twitchy. This new instability has consequences, and it's not just geological. Our technology and the entire natural world are built on an assumption of stability that has just been violated. Think about it. Every single satellite we have is in an orbit calculated with the moon's gravity as a constant. When that variable blinks out of existence, their orbits shift by meters. Now, that's enough to completely ruin the precise timing needed for GPS, for telecommunications, for the internet to function. Systems everywhere start logging errors, saying, that's not supposed to happen. But before our computers even flag a problem, the animal kingdom is already in total chaos. So many species use moonlight to migrate, to hunt, to reproduce. Sea turtle hatchlings, nocturnal predators, even the daily migration of plankton, which is the largest movement of biomass on Earth, it all goes wrong. Instincts misfire, and the predator-prey balance shifts within minutes. And that's the crucial point. When the fundamental timing of an ecosystem is broken, the damage isn't temporary. It triggers a cascade of failures that won't just reset itself when the moon comes back. And speaking of the moon coming back, after 1 hour of darkness, chaos, and confusion, it reappears instantly. And this is the most dangerous moment of the entire event.
Gravity doesn't gently resume its duties. It snaps back into place with the force of a 73 quintillion-ton rock reasserting its presence in the fabric of space-time. The tidal bulges reform instantly. Water that was sloshing around unpredictably is now violently yanked back into a pattern it had just abandoned. The result is not a clean reset. It's chaotic coastal surges, unpredictable flooding, and geological and oceanic aftershocks that would continue for days. Which brings us all the way back to Maya's original question. After all this chaos, would we actually be okay? And the answer is, yeah, we'd survive. Civilization is still standing, cities are still there, the internet eventually resyncs, but something fundamental is lost. We lose coastal infrastructure, we lose ecological timing, but most importantly, we lose our trust in the predictability of the universe. We learn that our entire world is built on assumptions we never even knew we were making. And this is the ultimate takeaway. The moon's true power isn't in some dramatic, destructive force. Its power is in its silent, boring, absolute reliability. That quiet predictability is the invisible infrastructure holding our world together. The scariest part isn't that the moon could disappear. It's realizing how much of our lives only work because it never does.
So, if you have a question like Maya's, one that sounds simple but quietly pulls at a thread of reality, we would love to hear it. Because sometimes the most profound discoveries start by asking, it's only an hour. What could possibly happen?